In this mini lesson, we're going to be looking to factor out a GCF from polynomials. So what the difference is whenever you see a plus or a minus sign in between each term, that separates the term. So this first example right here would be considered a binomial, bi meaning two, because there are two terms separated by the plus sign. In this bottom example down here, we have 1, 2, 3 terms, so this would be considered a trinomial. If we're looking to factor out a GCF from each one of them, we're going to look at numbers first. So between 18 and 24, if you look at the factors of 18 and 24, 18 has 1 and 18, 2 and 9, 3 and 6, and 24 has 1, 24, 2 and 12, 3 and 8, and 4 and 6. So if we look at these two lists, the largest number that both lists has in common looks to be 6. So we're going to look to factor out a 6. And then I'm going to look at x squared versus x. Because it's a variable, remember we look for the lowest exponent that both of them have in common. So this second term has 1x where the first term has 2 x's. So both of them have 1x at least. When you're factoring out a GCF from a polynomial, meaning there's more than one term, you're in essence dividing. So we have 18 divided by 6 is going to leave us with a 3 on the inside. And if I have an x squared and I take out 1x, I'm left with 1x on the inside. My sign stays the same. 24 divided by 6 gives me a 4. And if I had 1x and I took out 1x, I'm left with nothing. And the very quick, easy way for you to check is you know that parentheses mean multiplication. In your head, just very quickly multiply that back in. 6x times 3x is 18x squared, and 6x times 4 is 24x. So we know that we factored it correctly. This would be what our factored version of that binomial looks like. Greatest common factor is always the very first thing that you look to factor out. In this next example, I am looking at -9, 15, and -18. So I'm going to ignore the positives and negatives right now, but my factors of 9 are 1 and 9 and 3 and 3. 15 is 1 and 15, or 3 and 5. And 18 is 1 and 18, 2, 9, 3, 6. So looking at this list, I see that there is a 3 in all of them. So I'm actually going to pull out a -3 because I don't like this leading term to have a negative sign in front of it. So I see that -3 is my number, my greatest common number between all of them. And I look at the variables. I see that each term has an x. This first term has an x squared, the second term has an x cubed, the third term has an x to the fourth. The highest number, the highest power each term has is an x squared. I also see that each term has a y, so we can factor out a y from this. Not every term has a z, so we leave the z's alone. So as I go through and divide each term by our greatest common factor, which our greatest common factor is -3x squared y, I determine what's left. -9 divided by -3 is +3. X squared divided by x squared, there's no x left. Y divided by y, there's no y's left, but I see that I have a z left over. Now I have a +15 divided by a -3, so that leaves me with -5. I have 3 x's, I'm taking out 2 of them, so I have 1 x left over. I have 1 y, I took out 1 y, so all my y's are gone. -18 divided by -3 is +6. I have 4 x's, I take out 2 of them, so I have 2 left. I have 2 y's, I took out 1, so I have 1 y left. And if you go ahead and again in your head very quickly distribute back in, you can see that we did factor it correctly, and this is what my factor looks like.